All right, this is part one of the rational functions part two test, which is a little bit confusing, but this is our second test on rational functions, and this is going to be the first part where I cover all of the algebra type problems. For the first question, the structure that we have here is two fractions that are set equal. Of course, they're rational expressions because the x is on the bottom. The approach that we should take for solving this is using cross multiplication. So I already went ahead and multiplied this top numerator by that denominator and wrote it like this. So you can see because I recognize these as being conjugates and their product as the difference of squares, I went ahead and already did that there. The other cross multiplication, I just left the 4 outside so then you can see me distribute all of that in. All right, so when this is distributed in, you're going to get a 4x squared minus 64, and that's going to be equal to 4x squared plus 8x minus 32. One benefit that you do see in this problem that you might not actually see in the test is that your quadratic portions of these do cancel out. If it doesn't, you might get into a little bit of factoring in. If it does cancel, then great. Makes it a little bit easier for you. All right, we do have the 8x on the right, so I'm going to keep that over here. The negative 32, I'll go ahead and add that on to this side. And when I add that on, it's going to drop it down to a negative 32. Yeah, it sounds a little bit weird, but when we add that on, you're actually going to subtract from the negative 64, but maintain that negative sign, so negative 32. When you divide out, you're going to get x is equal to negative 4. Okay, when you are done with any of these problems, which are going to be the first two on the test here, when you're done with these, you need to take that answer and then go back and look at the denominators that we started with and make sure that these numbers are good. As you can see, that negative 4 isn't going to go in here, and well, it's not going to work in there because it's going to give you a 0, which is going to make this undefined. So this solution is what we're going to call the extraneous solution, being that that is our only solution in the problem that we would have had. The final answer here is going to be no solution, which might kind of throw you off that we're going to have one of those. But look, if you can go all the way through the work and you do get an answer that happens to make that equal to a 0, then that's actually a good sign that you've done good work. Because be looking for that there's a chance of an extraneous solution. All right, in the second problem, my class has been doing something where we call it the happy cyclops, and though it works good for this problem, I think the approach that I want to cover with this, because of how it pertains to one of the word problems and just in general, anyway, I want to do a different method here, which is just to find the common denominator. So you look at all the denominators that we do have here, and you've got the x minus 1, which obviously matches this guy, and then that one's an x. Now, I shouldn't need to state it, but I'm going to. You cannot simply just subtract a 1 on the bottom here, then subtract a 1 from the 2, and call that a common denominator. These are just different types of factors. So you need to be thinking that every one of our fractions needs an x, and it also needs an x minus 1, but not an overlapping of them. They're just two separate things. So your common denominator is going to be an x and x minus 1 like that. That's what it's going to look like. So the way that I approach this is I really kind of look at what are the bottoms, what are they missing and what do they need, and then I will adjust the top. But ultimately, you don't need to worry about the denominators later on. So since this is over an x minus 1, it just needs that x, so you'll see that I added it next to it. I got the minus 2, and this fraction has the x on the bottom, so I need an x minus 1, so there it is. The 1, even though it doesn't really do anything as its own, later on I wanted to show it and then let you see that you have the x that gets multiplied because it already has the x minus 1. So you don't really need to worry about the denominators except for the fact of checking for extraneous solutions at the end. So this is really the equation that we're going to work on. These are going to multiply to give you an x squared. This is going to distribute in, give you negative 2x, and plus 2, that's going to be an x. So we'll just go ahead and move that x over. We're going to get negative 3x in the middle, set equal to 0, and because you have a quadratic that didn't cancel out like in the last one, you're going to factor. Okay, and everything on this test, because we're not using a calculator, you can expect that these are going to work out pretty well. Sure, you got to factor, but they're not going to be the worst numbers that you could see. All right, multiply to give you 2 and add to give you -3. That's going to be a -2 and a -1. Their product is a +2, and they add together to give you -3. So our possible solutions are going to include a 2 and a 1, the numbers that make that 0. So now we just go back up to the top and we check to see what we've got. The 1 is not going to work here. That's going to give you a 0 and undefined, so we'll take that out. The only other number that would not work would have been a 0 that would have gone in there. So 2's good to go. We'll just take that out. We'll box up the 2, and there's your answer. If you don't get any extraneous solutions, that's possible as well. You can get 2 answers, you can get 1 answer, you can get no answers. Okay. Assuming that we take it all the way to a quadratic. Sometimes you don't even have to worry about 2 possible answers. All right, the other parts of the algebra are going to include the word problems that we have. The work problems, in my opinion, this should be one of the easiest things that you do on the test. This is the template that I use. So if you're from another class and you may be watching this, this is a different approach at how I do this maybe than you've been instructed, but this is how I'm going to go through it. All right, what we have in any of these situations is 2 people, or possibly more. We're going to focus on 2. You're going to have 2 people that are doing a job together, but we're also thinking about how long it takes them to do the job separately. So each of the fractions is going to represent one of the people. The top of the fractions are always going to be the same, and they're going to be the amount of time that it takes for the 2 people to do a job together. The bottoms of the fractions are going to be the time it takes the people individually. So that's where it becomes unique to each person. Okay, so you got Tomas and Jerry, and they're going to be tiling a kitchen. It says that Jerry thinks that if he worked alone, it would take him 3 times as long as it would take Tomas to do this. So what we're going to do is let Tomas be a time of X, whatever number of hours that might be. And then Jerry's is going to be 3x. So you got that connection there using the same variable. Okay, so since we don't know that, it's probably going to tell you what it takes them to do this together, which is what it does say here. Working together, they can complete the job in 6 hours. So that's going to go in both of those places. Now from here, again, my classes might be doing this little cyclops thing that I showed them, but don't jump straight to that, because if your common denominator is easier to just find, then go there. Like in this case, you have an x versus a 3x. Just multiply each side by 3, and you're balanced. If you do all the other stuff with what I'd shown with that cyclops deal, you're going to get a quadratic, and that's unnecessary in the problem. It just creates extraneous solutions. So if you find your common denominator like this, you can have an 18 plus 6, which is 24, and then your common denominator already is a 3x. Set that equal to 1. Now, the only way that this fraction can equal 1 is if 24 is the same thing as 3x, and it gives you 1 whole. Top and bottom the same, give you 1. So then if you divide by 3, x comes back as 8. Okay, so now I boxed it, I boxed the 8, but the actual answers that we're looking for here are going to be 8 and 24. That's the times that they're actually going to take. So 8 hours for whoever the fastest one was, and then the slower guy is going to be the 24. So those would be the answers that we're looking for, and we'll leave little blanks so you know that you've got to actually state both answers. It'll take care of itself. You just got to get to that 8. Okay, distance, rate, and time. There's 2 different problems that we're going to show you here. There's one that I refer to as the easier problem, which is going to have this phrase in it. It's going to say in the same amount of time. Okay. These charts, regardless of what type of question you're going to be doing for distance, rate, and time, are going to be pretty helpful here. There's 2 things that we're usually looking at. Maybe they're people or their events or some distinguishing characteristic there, and then they each have a distance, a rate, and a time that goes along with them. In this problem, you see right there where it says in the same amount of time, the times you just know that they're the same. So I usually put an equal sign just sideways like that. Okay, in this question, Morgan's boat will go 10 miles per hour in still water. So if there's no current, it's just 10 miles per hour. If he can go 8 miles downstream in the same amount of time it takes him to go 6 miles upstream, then what is the speed of the current? So our 2 events are going to be upstream and downstream. Now, upstream is going to be the more difficult because the current's working against. The downstream is going to be the one that's easier. You're going faster in that one because the current's helping you out. So we'll see here that going downstream, we're able to go 8 miles in the same time you can go 6. I'll put those in backwards, sorry. I said it correctly though, I believe. Okay, so you can go downstream 8 miles if you go upstream 6. So it's easier to go downstream than it is up, and that's why that distance would be greater here. As far as the rates, what we don't know is what the current is. So we start with the boat speed of 10, and then say in upstream, the current is going to be taken away from it. And when you're going downstream, the current's going to be added onto it. Okay, now, once all that's filled in, this phrasing right here, again, is going to tell you what the structure is. Because the times are equal, well, normally I would start, when I teach this stuff originally, I'd say the time upstream is equal to the time downstream. Okay, but time can be calculated by dividing the distance by the rate. So I'm going to substitute in the 6 over 10 minus x. That's the distance divided by its respective rate. And set that equal to the other one. And what you end up with here is a cross products problem. And in this type of problem, you also can't create a quadratic. So you can find out the math is pretty quick from here. All right, multiplying this way, you're going to get 60 plus 6x. Then multiplying that way, you're going to get 80 minus 8x. Because I have a negative 8x, I'm going to add that on and get to 14x. And at the same time, because I know I'm moving my x's over here, I'll just take that 60 and I'll subtract it over onto that side, and I get 20. So to conclude it, you're just going to divide divide 20 by 14. So x is going to be 20 over 14. That does reduce down to 10 over 7. For the test, you do not get to have a calculator, but don't worry about needing to do division here. That's all kind of worked out, and just assume right now that that would be a fine answer, and then don't think twice about it, and everything will be okay. In other words, if it is a fraction, just box it up and move on, but believe me, we've already sorted out those details for you. And that's it. You don't need to plug it back in to find any other things here, because you're just asked a single question, which is the current speed. So, anyway. All right, last question for this video. This is going to be the more challenging distance rate time problem, and we are aware of that when you're going into this, and hopefully we've prepared you for it appropriately. I do have a little typo here. It's supposed to say does, and that's why I circled it for you. Okay, Mike and Ike. I'll go ahead and fill those in. I know that's what's here. Okay, Mike and Ike are two twins who like to cheat at 10K races. Mike will begin the race, and he maintains his pace for 8 kilometers. So there's his distance that you're getting. Ike then takes his place and finishes the race, which the difference between 8 and 10 is going to be 2. So that's his distance, and it says it later in there anyway, right there. Ike takes his place, finishes the race. If Ike can keep a pace of 4 kilometers per hour faster than Mike during his 2K part of the race, and the total time is 36 minutes, etc., etc. Okay, so let's just talk about the rates here. Ike is 4 kilometers per hour faster than Mike. So I'm going to call Mike X, and then Ike X plus 4. Now the times here, they're not going to be equal to each other. We don't get that part. But we do get a combined time of 36 minutes. So like in the last one where I set them up as fractions, I'm still going to do that. I'm going to take the distance over the rate, but I'm not going to set it equal to the other one. I'm going to have to add them together, the 2 over x plus 4. I have to add them and then set them equal to what the final time is, which is the 36 minutes. Now you'll see that I put it in a fraction here, 3/5 of an hour, because your rates are actually based on hours. So we'll just swap out 36 minutes and put in a 3 over 5, which I hope you see right now is already nice because we've got fractions. Everything's kind of nice with that, across the board. Okay, so now this is going to start to look like the problem that we did here where we need a common denominator. And your common denominator is going to be the 5, it's going to be the x, and it's also going to be the x plus 4. All those things together. So each of these is really missing 2 parts. And that's different than the last one or that problem at the beginning where they were only missing 1 each. Okay, so the 8, let's see if we can do it this way. So the 8 is going to need to get a 5 and also get an x plus 4. And also that's happening in the bottom, but I'm not going to write that stuff down. The 2 is not going to need the binomial. It's going to need the 5 and the x. It needs those 2 things. Okay, and then the 3 is going to need both of these, and I'll just go ahead and multiply them now because that's pretty easy. So x squared plus 4x. Okay, and then we're going to multiply everything that we can to clean things up. This is really just a 40 that's going to distribute in. So you can get a 40x plus 160. This is going to be a 10x. Over here you get 3x squared plus 12x. That's the part where you realize you don't like this. The numbers being higher aren't too bad. It's once you get that quadratic. Okay, so let's regroup everything, knowing that we have a quadratic. These x's are going to group up, and I'm going to subtract all that. That's 50x. I'm going to subtract it from the 12x. So that's going to give me negative 38x. Then the 160 is going to move over to here. Okay. With this question, the numbers are large, and I'm aware of that. The test is not going to have numbers that are as big as this. Okay, because now we're starting to look at factoring by parts, and yes, I know these are high numbers, so don't get too worried about that. It'll be all right for your test. We put the bad problems on the review, the best problems on the test. Okay, so these multiply together to give you negative 480. So you need to find two things that multiply to give you negative 480, but also add up to give you negative 38. Those numbers, it might take you a little while to sort through them, but they end up being negative 48x and a positive 10x. Might actually be the first choice that some people would choose to go for here. Okay, then we factor by parts, and we're almost done. And I'm going to have to move over somewhere else to do the rest of this. When I factor that by parts, I'm going to use my GCF, so I'm going to take out a 3 and an x, and it's going to leave behind an x minus 16. And then from here I can divide out a 10, and it leaves me also with an x minus 16. So that tells us all this stuff is working. And yes, this is all set equal to 0, but don't worry about it. Okay, so our possible roots would include a negative 10 over 3, and also from these two, 16. And I didn't really finish rewriting it all factored. I'm just taking my answers from there. Okay, but since this is representing a rate that people are running at, that is out, and your answer is right here, 16. So their individual rates, though, are going to be 16 and 20. I should probably box that one as well. All right, in the next video, we'll tackle all the graphing stuff, which you might already see me setting up and getting ready for.